Today we're going to talk about a special case of infinite geometric series called a power series. A power series is something that looks like this. So this is just a sub 0 plus a sub 1 times x plus a sub 2 times x squared, and so on. So that looks kind of complicated just because there's a lot going on. So let's look at the simplest one. And that's going to be 1 plus x squared plus x cubed, and so on. So it's called a power series because it is a series, the sum of the terms, of things that have powers. So this is a power series, and hopefully you can see, even though it's kind of funny, this is an infinite geometric series. Because we have a common ratio. Okay, so what is that common ratio? What are we multiplying to get from here to here to here to here? We are multiplying by x. So we can find the sum of an infinite geometric series as long as our common ratio is between -1 and 1. So is x between -1 and 1? The answer is sometimes. If we pick the right value of x, it will be. If we pick the wrong value, it will not be. So we can find the sum of this series. So the sum for this series is going to be a1, which is 1, over 1 minus r, which is x. We just have to have the condition that the common ratio, which in this case is x, is between -1 and 1. Okay, that condition, this thing that needs to be met, has a special name when we're talking about power series. The special name we give to this is called the interval of convergence. Okay, interval of convergence. And we're going to talk about that term convergence, and next week we're going to be doing convergent and divergent series. But convergence is what it sounds like. So what we're going to do is look at this on a calculator. So what we're trying to say is that if I add 1 plus x squared plus x cubed infinitely, that this is 1 over 1 minus x, as long as my x is between -1 and 1. So what we're going to do is use the calculator. So we're going to investigate this on the calculator. So on the calculator, we're going to have a window from -5 to 5 in both the x and the y. In y1, we're going to have the sum of the series, so 1 over 1 minus x. In y2, what we're going to do is we're going to add terms, and we're going to keep adding on terms here to see what is happening. So here's our calculator. My window's set from -5 to 5 in the x and the y. In my y equals, we've got the 1 over 1 minus x and the first two terms of the series. So if I graph, this is the 1 over 1 minus x. And then that is 1 plus x. So a line, that should be no surprise. And notice that they do match each other right there. So now what we're going to do is we're going to take my series and we're just going to keep adding terms. Okay, because what we're saying is that this infinite series is equal to this. So if we add an x squared, we get a parabola, and again, it's matching this curve right here. So let's add on another term. Okay, x cubed, and graph. So it's matching up this graph, but only on a very specific part of the graph. I'm going to go ahead and zoom in just to get a better picture here. So it's matching but only when the graph is in between these two values, which is -1 and 1. Now, as I add on more and more terms, it's going to match up greater and greater and greater on that interval. So that's the interval of convergence. Those two graphs are converging to each other. They're matching, but only in that window. When we're not in that window, it's very, very much not the same thing. So that's why between -1 and 1, those two are the same. Outside of -1 and 1, they are not. So let's look at a different series. So we've got 1 minus 2x plus 4x squared minus 8x cubed and so on. So this is an infinite geometric series. The common ratio is going to be a -2x. So we will be able to find the sum, and that'll be our next step. But first we want to identify the interval of convergence. So where does this equal that? So we're going to take our common ratio, which is -2x, and that has to be between -1 and 1. So then to solve for x, we're going to divide both sides by -2, which makes this a +1/2, but it switches the sign. So my interval of convergence is -1/2 to 1/2. So as long as my x is a number between -1/2 and 1/2, we can find the sum of this power series. So after we found the interval of convergence, which was -1/2 to 1/2, we are asked what function is represented by the series. And this, for our purposes, is just a fancy way of saying find the sum. So we are going to represent it as a function, so f of x. It's going to be a1 over 1 minus r. Well, my a1 is 1 over 1 minus, my r is a -2x, so this would be 1 plus 2x. Next, we want to look at the graphic example of this. So we want to physically see how this and this are somehow the same. So we're going to graph f of x and the first 3 terms of the series. So in y1, we're going to have f of x, which is our sum. So 1 over 1 minus r, which in this case is 1 over 1 plus 2x. In the second one, we want the first 3 terms of the series. So it's going to be 1 minus 2x plus 4x squared. And I could ask for 8 terms or 2 terms, but we're just asked for 3 terms. So that's what we're going to plug into the calculator. So in the calculator, I've got the 2 functions. My window, I just have them going from -4 to 4 in each direction. And then we graph. And what we're looking at is, again, how the 2 graphs match up. But in this case, it's between -1/2 and 1/2 where they meet up. So next, we want to find f of -1/3. Well, the first thing we have to check is, can we do it? So is -1/3 in between -1/2 and 1/2? And it is. So we can plug it into f of x, which is going to be 1 over 1 plus 2 times the -1/3. Okay, which is going to be 1 over 1 minus 2/3, which is going to be 1 over 1/3, which is going to be 3. Last part of this problem is similar. Find f of 4/3. Okay, well, what we have to do before we plug it in here is to check if we can. Is 4/3 between -1 and 1/2? It is not. So this does not exist because it's not in between here. Again, you could plug it in here and get a number. It's just not the number that will represent the same thing as if I plugged 4/3 in here, because this is just going to keep getting bigger and bigger and bigger, even though that will be one value. So just check if it's in the interval of convergence, plug it in. If not, you're done. Next, we are going to write an IGS. So IGS, again, is infinite geometric series, whose sum is 1 over 1 minus 4x. and identify its interval of convergence. So my sum formula, a1 over 1 minus r, we're saying that is equal to 1 over 1 minus 4x. So we're just going to take the pieces. My a1 is going to be 1. My r is going to be 4x. So my infinite geometric series starting with 1, then multiplying by 4x, so 1 plus 4x plus 16x squared, and so on, is going to be my series for the interval of convergence. I want my common ratio, which is 4x, to be between -1 and 1. That will happen when I divide by 4. If my common ratio is between -1/4 and 1/4. All right, so we're going to find the interval of convergence and find an expression for the sum of this series. So it's still a power series, it just looks a little bit more complicated. So we've got 2 plus x minus 4 plus 1/2 x minus 4 squared plus 1/4 x minus 4 cubed, and so on. So my common ratio is what we're multiplying to get from term to term, which is going to be 1/2 times x minus 4. Well, for my interval of convergence, that means I need that whole thing to be between -1 and 1. It's always between -1 and 1. And then we're going to solve for x. So I'm going to multiply everything by 2. And then add 4. So -2 plus 4 is 2. And 2 plus 4 is 6. So there's my interval of convergence. My sum is going to be a1, which is 2, over 1 minus r, which is still 1/2 times x minus 4. Now you could certainly simplify this down, but you don't necessarily need to. So I'm just going to leave it just like that. So my last example, just another way we can look at series. So this says solve for x. If 8x over 4x minus 1 is equal to x plus x squared plus x cubed plus an infinite number of terms. Well, algebraically that's a little tough if you get an infinite number of things, but we can rewrite this as a1 over 1 minus r. My a1 is x. My common ratio is also x. So now I have just a simple algebra problem. So cross multiply. Then I'll move everything to one side. So 0 equals 12x squared. X minus 8 is 9x. Factor out a 3x. So either x is equal to 0 or x is equal to, when I solve that one, 3/4. Next, we are going to be asked to write the series and find its sum. So we have two different cases, either x is equal to 0 or x is equal to 3/4. Well, x equals 0 is easy. The series is going to be what we plug in here, which would be 0 plus 0 plus 0 and so on, which is sum is going to be 0. When x is equal to 3/4, that means we have 3/4 plus 9/16 plus 27/64, and so on. The sum then I can plug into the a1 over 1 minus r, so 3/4 over 1 minus 3/4, which would be 3/4 divided by 1/4, which is 3 for my sum. You could also plug it into here and you'd get the same thing. So that is power series.